Hey folks, today we are diving into Rust. Our mission is to craft an algorithm to determine whether two items from a list can add up to a specific target. We will explore different solutions to this challenge by using Rust and compare their performance. Plus, we will build some tests to ensure our code operates smoothly. So let's get started. First, let's outline our goal to have a clear focus and documentation simultaneously. So let me create the documentation here. So we will have a function called TargetSum. So this is the name of the function, uh, and we'll write down here what this function should do. So function to find whether or not two items from the list sum up to the target. Sum up to the target. Okay. Um, let's define the arguments for that function. So we have a list of values that will be a vector with all the items that I want to search. So this is a vector I size. I'll be using I size here, so the compiler can decide whether this will be I32 or I64 depending on your computer architecture. It's the same thing for the target. So those are our args, and this function we return a vector as well with the I size type. So this will be the numbers that sum up to our targets. So let's define some example here to make it clear. So for example, let's create some Rust code here inside. We have, for example, a result. It is a vec with the I size type, and when you call TargetSum with a list of items 1, 2, and 3, for example, and you want to find if there's at least two numbers that sum up to 5, the result should return 2 and 3, because if you sum 2 and 3, these will result to 5. Okay, so this is our documentation. I think this is clear. To guide our implementation, we will start by creating our tests. So this will help drive our solution. So let me see here to create some first tests. We're using the CFG macro with the tests, and create a module test here and import some functions that I will import on a single function that will be our TargetSum function that I haven't created yet, and define a test here with the function. Let's see if we can find 1 and 4. So target sum returns 1 and 4. Okay, and assert equal. If you call TargetSum with a vec with, for example, number 1 and 7 0 4 and 8, and you want to find the number 5 as a target, so it should return 1 and 4 because 1 plus 4 is 5. Okay, this is the argument for the function. Let's close here and define our results 1 and 4. I think there's something wrong here. The vector. So yeah, TargetSum will receive a vector and the target number, and then set equal. If you call cargo test, it should fail. This is expected given that we haven't created our function yet. So let's create our first implementation here. I'll be using a Navy implementation to get started. So we have a function called TargetSum that receive values, is a vec with I size. We also have a target with I size, and this should return a vec with I size as well. Okay, so if we return a vec with 1 and 4, this test should pass. Let's see, cargo test. Yeah, the test passed, it's green. So let's try to implement this here. So to start things, we can have a multiple result that will be our vect with I size. This is a vec, it's an empty vector that you can define here. Okay, it's a new vector, and we need to loop through these values and see sum all those numbers and check whether there are at least 2 numbers that sum up to the target that we want. So we can do that with a simple for loop and 0 to the values on the number of the values as a range, -1 to remove the last one, and we can do another loop here, and 1 to the values of length, okay, So here in this first line, we are going from 0 to the last number minus 1, so that we won't reach the last one. And here we will starting from the second to the last. So by doing this, we will loop through all the numbers we have in the list. And now I have to check if values I plus values j is equal to target. We are going to store the values we've just found. So result dot push values I and result dot push values j, and at the end we will return the result. I forgot to add a parenthesis here. Okay, I wrote that wrong. Okay, let's see if that works. So run cargo tests. Okay, it seems it's working. And now I will add another test here, just to ensure things are really working. So let's call our macros test again and define, let's see if h and 1 sums up to 9. Target sum returns 8 and 1. Okay, here assert equal, let's call TargetSum with our vec. Let's pass some numbers here: 1, 7, 9, see 4 and 8, and we want to find the target number 9, and 9, it should be 1 and 8, so this vector should return 1 and 8. Okay, let's run our test again. Okay, it seems that it's working. As you can see, you have two loops here, one loop and a second loop, resulting in a time complexity of all 1 O and O n squared, because it's looping twice, which isn't great. However, our space complexity remains constant at all 1. So time complexity O n squared and space complexity is constant, 1, since we only store results in the list for valid cases here, so this list isn't increasing. So okay, time complexity and space complexity. Now let's create some smarter. We can use a hash map to store values and compare them with a single loop, and improve our time complexity to O n instead. Let's try to do that here. I will comment that code and create another one. So when target sum receive values is a vector I size, also receive target I size, returns a vector with I size. Okay, and we want to use a hash map for this case. So in order to use the hash map, we need to call it here from the standard library collections, and I think hash map. I think that's the name. Yeah, I think that's correct. Hash map from collections, and let's create our results again. Result is going to be mutable because I want to store values here. It's a vec with I size equal vac new. That will be a new vector. Let's create a variable to store our hash map. So mult temp variable, that's gonna be a hash map. It will store the I size value is a simple bool. That's going to be a new hash map. Okay. I'm calling it wrong. I think you can call it this way. And this is going to return the result. If we call our tests again, cargo tests should fail. Yeah, 2 tests are failing. Let's try to implement our solution here. So for this case, we want to loop through our values again, but this time we can loop with a simple for, because this will be a single loop for val in values. We want to see if the item we have is equal to our target minus the value we have here at this current time. So it's like target minus val. Let's use an absolute value here to avoid this thing be negative. What's happening here is, for example, if you have a target of 5, let's imagine our target equals to 5, and we have a list, for example, with 1, 2, and 3. For this case, what we're gonna do is 5 minus 1 equals to 4. In this case, 4 is not the target that we want, so that's not the number that we want. But for the second time, we have 5 minus 2 equals to 3. And as you can see here, we have the number 3 in the list. It means that we have the number 2 and also the result that we want, is the number 3, and for that case we can return 2 and 3 that sum maps to 5. So that is how this algorithm works. So in order to do that, we need to check if our temp hash map contains this number that we want. So we can do that with temp contains key. It's going to receive a reference to the item, and if that is true, we want to store our item in the results, and the value that we found here in the result as well. Otherwise, if that's not true, we want to insert into the temp the value that we found. You just say that's true. So now the value is already stored here, and you can check if it's already here for this conjunction. Okay, and we are returning the result at the end. Let's remove it from here. Return the results. So let's check whether this works or not. Cargo tests. So it seems it's working, and we can add one more test here just to ensure, for example, negative case. Let's see if in the list we are passing if the list we're passing doesn't have at least two numbers that sum up to the value we want to return an empty list, right? Because there are no values that sum up to the target. So for that case, TargetSum returns empty vector. Let's close here. Assert equal, and call TargetSum. Let's pass some vac here. 17948, and we want to find, for example, 20. So, and none of those numbers will sum up to 20, as you can see here. So there aren't at least two numbers that sum up to the target that we want. So for this specific case, we want to return empty vector. So a new vector. Okay, and let's run cargo test again. Yeah, it seems it works as well. And since there is just one loop, the time complexity for this case is just O n, because it's much better than the previous version. O n. But however, the space complexity worsens compared to the first case, as it depends on the values this time, resulting in O n for space complexity in this case, because the hash map is increasing according to the number of values we have. So in this case, the space complexity is a kind of worse than the previous version. So if you're worried with space complexity, maybe you need to try to find a third solution. There is a third solution, but I leave the challenge to you. Explore and discover it for even deeper learning experience. If you're feeling curious or a bit lazy, you can find the third solution on my GitHub, okay? So space complexity here is also ON. Okay, that's it for today, guys, and thanks for watching.